So good evening, everyone, or good morning. It depends where you are joining us from. So my name is Daniil. I'm a Flutter developer now, and I'm using Flutter on a daily basis, which is great. So today I'm going to just talk about CI/CD basics with GitHub Actions. And the reason why I choose GitHub Actions is that there is not a lot of content online how to use GitHub Actions for Flutter, because mainly everyone focuses on other services, but this is going to be focusing on GitHub Actions. So let's start with what is GitHub Actions. GitHub Actions is just another CI/CD service. It makes it easy to automate all your software workflows. You have access to Linux, Mac OS, Windows, and ARM virtual machines, and also containers. It has a lot of third-party actions. Those are like the scripts that other developers wrote for you to use, so you don't have to maintain them. It only has YAML workflow configuration, so there is no pretty nice UI to do things quickly and easily. So there is a little learning curve to get it to work for you, for your app. It's also free for all public repositories. So if you have a public repo or a public project, you can basically use GitHub Actions for free forever, and it's unlimited. And it also has a very generous free plan, and it gives you a lot of free minutes that you can use to build your apps. And it's also a very new service. It's not been out for long compared to other services. So I'm just going to briefly mention the other options for Flutter. Bitrace is one of the services that's been out there for a while. It's actually mobile first service, so it actually aims at Android and iOS developers, and they also have Flutter support now. And they also support UI and YAML for creating your pipelines, your builds, your workflows. And it has quite a good free plan for individuals if you're not a big organization. It's a good free plan for your side project. And also there is CodeMagic. And CodeMagic started as a Flutter first CI/CD service. So they're probably the easiest ones to start with. If you're new to Flutter and you're new to DevOps and CI/CD, they're probably the best ones to start with. They also have UI and they also have YAML support for their workflows, and they have a pretty good free plan. But let's talk about why GitHub Actions. Why would you choose GitHub Actions over other competitors? I'm not really comparing the features between the two or why, but I'm just saying, in my opinion, why GitHub Actions is slightly better than maybe other options. First of all, it's free for public repos and very generous free plan, as I mentioned before. And you get also like free extra build minutes with your pro plan, team plan, or enterprise account. Because I know that a lot of people already use GitHub just to have their source code there. And some of them already pay for team plans or pro plan. And you get extra minutes because of that, or for free, which is good. Your code and your CI configuration and CD configuration lives all in one place. And so it's in your repo, and where the GitHub Actions are all together with your code. And it really nicely integrates with pull requests, issues, and your projects in GitHub, on your GitHub repo, which is actually pretty nice to have everything just in one place. The other good point is that it is used by big names. Big names started to use GitHub Actions, and that's really good. One other good point is that it has a lot of open source third-party actions. And those third-party actions, those are like scripts that do things that you want them to do. They're doing specific things, and they're all open source, so you can actually even fork them and use them in your workflows. So let's move on. Why not to use GitHub Actions? Well, this shouldn't actually be here. I thought I skipped this slide, but I wanted not to talk about that. But anyway, sorry about that. So there are a few things that we need to get ready before we can start using GitHub Actions. First of all, we need to set up, make sure that our app is set up with signing keys and certificates. And there are official guides from Flutter on how to set up deployment for Android and iOS. And they actually talk about how to configure signing keys, how to configure certificates, how to create everything for Android and iOS, and how to configure each project in Flutter. So I'm not going to cover that today because that's a separate subject and it's quite lengthy. We also need to prepare an export options list file. This is an important one to generate an IPA file that we will be using for iOS app. There will be later on, I will add how-to steps on the repo. I've also put a link to the repo later, and I'll paste it into chat as well. But you'll be able to actually see the steps how to quickly get export list file generated. You can also Google how to do it, but you need it to generate an IPA file. You also need your Google service account to be able to publish and deploy your apps to Play Store, and that is required. And there's a good tutorial how to do it, good guide on Fastlane tools. We are not using Fastlane for this example because this is just basics CI/CD, but Fastlane is another great tool that helps you to improve your DevOps process for mobile apps. But that's not going to be covered today, but they have a good guide for Android. And we also need to prepare Apple certificates and Apple credentials and app-specific password. So this is also covered in the signing keys and certificates in the Flutter official deployment guideline. So after we have all that information, we just need to add it into GitHub Secrets. So GitHub Secrets is a place where you can store all the secret information away from basically spine eyes. So if you add it in there, no one will be able to see it. And the first time you add it, you will see, you give it a name and you give it a value. And you will only see the value once when you add it in. And then you can only update this value. So you need to also separately store your secrets somewhere safe on things like 1Password or LastPass to make sure you don't lose them. Because once you add them here, you won't be able to read the values back from GitHub Secrets. You also need to prepare your files, your certificate files and code signing files. So one limitation of GitHub Actions at the moment is that GitHub Actions doesn't have any ability to save and store files as secrets. They only store, as you have previously seen, that you can only store a string value as a secret on GitHub Actions. And one workaround is to actually encode all the files as a base64 strings. So there is this little script. All the slides, by the way, also will be available on the GitHub repo. So you can actually encode all your files, your certificates, B12 files for Apple and mobile provisioning profiles, and the key store file for Android. That could be all encoded into a 64 base 64 encoded string and put into GitHub Secrets as a plain string text. So that's one nice workaround. And the steps that we need to take to create our workflows. So this is like the basics of how this will work with GitHub Actions. We need to run the tests and code analysis for Flutter. So this kind of makes sense to do that on the CI to make sure that none of your tests are broken and that you are following the code standards and all your lint rules have been satisfied. Also, we need to set up code signing on the virtual machine because GitHub Actions gives us basically a virtual machine that we can use, and it's a fresh virtual machine. It doesn't have anything set up from our side. It already has pre-installed software on it, but there is nothing that actually is directly directly linked to our app. So we need to set up all the code signing from scratch on the VM. And we also need to set up Flutter because all the virtual machines, they don't come with pre-installed Flutter. They come with pre-installed Dart, but not Flutter framework. We need to build the app, either Android, iOS, or web. And after we build the app, we need to upload the artifacts. So we can upload those artifacts to GitHub Actions, and so that we can later download them manually from there. And we can also deploy those artifacts that we've built to Play Store, App Store, or Firebase hosting, or any other service that we are using. So what I'm going to do, I'm going to actually go into code, because I think theory is good, but code is better. I'm going to share an example. This is the code from the repo that you will have access to, and it's a public repo. So how GitHub Actions work is on your repo. So this is a fresh Flutter code, Flutter app. It's just the one that you create with Flutter Create. To get your GitHub Actions workflows to be picked up, you need to add a .github folder into your repo, into the root of your repo. And then you need to add a workflows folder. And inside your workflows, you will have all the workflows, all the YAML code for your workflows for GitHub Actions. So in this case, we are using one file, because this is just a basic and straightforward setup. And this is, everyone who is not familiar actually with YAML, it's not really straightforward. There's not really one standard for how to use YAML. The syntax is kind of the same, but YAML, the most important thing in YAML is the spacing. But there's a good guide on the GitHub website how to actually use YAML and how to actually read YAML syntax for GitHub Actions, which is a pretty good guide. So this is the YAML for GitHub Actions, how it looks. There are a few things that we need to set up to make it work. So you can actually see that there's quite a bit of code, but this covers a lot. So just bear with me, I'll explain what this does. So the name, everywhere you see a name tag, name, I don't know, tag parameter, what it's called. But everywhere you see this is just for visuals on your GitHub Actions website. So this doesn't do any functionality, just for you to actually see what this thing is actually called, if you want to give it a good name. Then you need to set up your triggers. Triggers are what is going to trigger this workflow. There could be many different triggers, one of which is pushes to branches. So you can actually build this workflow every time you push to main branch. So that's the case here. Also, you can have a trigger for pull requests into your specific branches. And this will, whenever you create a pull request, this will trigger a build on GitHub Actions. You can also have scheduled triggers every day or every week. So you can find the syntax for that online as well. And there are many other ways you can trigger workflows. And one way would be the manual way as well, for which you need to add workflow dispatch. This allows you to manually run a workflow and not just automatically. If you move on to jobs, so every workflow in GitHub Actions has a list of jobs. Jobs are basically the instances of virtual machines that you are going to use to run specific steps on GitHub Actions. So in our case, if you've seen before, we need to analyze the code and run our tests. This is done pretty simply. What we have access to here is that we have access to what machine we can use to run, what virtual machine we can use to run on GitHub Actions. And in our case, we are running this on Ubuntu latest, which is a Linux machine, which is also one of the cheapest virtual machines that you have on GitHub Actions. And usually I run everything on Linux when I use GitHub Actions, and only build iOS app on the macOS machine because that's the most expensive machine of them all. You can also set up your timeout minutes because you don't really want the job to actually freeze for some reason and stop executing and just run there for hours and waste your minutes and bill you at the end of the month. And then you have a list of your steps. The steps are basically kind of like scripts, actions that they need to be executed in a specific order for this job to be successfully complete. So one of the main steps that you most likely always do is you check out your source code of your repo. This is simply done by this action, which is a first-party action. How do you know it's a first-party action? Is it has this keyword, this word that starts with actions slash. So everything that starts with action slash comes directly from GitHub. So GitHub takes care of updating this action. And after that, we need to set up Flutter. And so this uses a third-party action by Subosito. I'm not sure how to pronounce this. And this is actually a repo of the name and the name of the action. And so you can actually highlight this, copy it, and Google for it, and it will take you directly to the repo of this action. You will see the source code for it. And this action allows us to set up Flutter to a specific version. We can actually use a channel, and you can say like, okay, channel, it will always be a latest stable channel in this case, or you can set it to dev, alpha, master, or you can actually use a specific Flutter version if you have to run it only against that specific version because you know that it works, and then manual upgrade when you're ready. The next steps for code analysis and testing is to get all dependencies. So all of this stuff is very similar to how you would do it through a command line on your machine when you're trying to build your app or run Flutter analysis or your Flutter tests. You're exactly doing the same, but on CI, on using GitHub Actions. So this just gets our dependencies and then runs Flutter code analysis and then runs tests. If one of these fails, all of the workflows fail. So this is kind of a protection for your code, for your app, so it doesn't build broken code or an app that fails testing if you have any unit tests. And so now let's move on to the Android job. Android job is very similar to that, but instead we are building the Android app now and not just running tests on it. And the only difference that we have here is this needs key. And this needs basically says that we need the code analysis and testing job to pass successfully before this Android job can start. So just in case we introduced an error and one of our tests fail, then the Android job and the other jobs will never start until we actually fix this and push fixes. And the steps for Android are a bit more complicated. We are doing the same checkout repository step, and then we need to prepare our code signing and our keys for signing the Android app. And the way to do it is that we have actually added them to the secrets of GitHub, and I will show you later exactly on GitHub where to actually add them and how they look like. So this actually specifies that we can actually take it directly from secrets on our GitHub repo. So when we prepared all our secrets, all our files in base64 format, we added them here. This allows it to also hide any printout of these secrets into the logs on your virtual machine. So this will never be kind of leaked in the log files of your virtual machine of your workflow run, which is kind of safe and secure more or less. But what we need to do here is we need to run this script. And this script is basically, in our case, takes this secret base64 and turns it into a file, an actual file. So you can actually see here that it takes it and turns it into a real file. But because it was base64 encoded, we need to decode it and decode it into real files. So there's this code, so you'll have access to it on the repo as well. So you will actually see that this decodes the base64 string of our file into a real file. And this is done also for the key properties file. as well. So you can actually see that there is this working directory for Android, and this is basically an extra option that you can set to say that this script that you're running here, this is an inline script, you want it to actually execute in this directory. If I didn't include this here, I would have to first do something like cd Android to move into that directory before I can actually run all these commands. So this is a little bit of a little cleaner way of running a script in a specific directory on the virtual machine. So here we also need to then set up Flutter. One of the limitations currently with GitHub Actions is that you cannot reuse steps, reuse set of steps in many different jobs. Because, for example, setting up Flutter and checking out repository will be used for everything, for running the tests, for building the iOS app, building the web app. But the problem is that we cannot reuse them, so we have to repeat the same code. And so you'll see this multiple times. And then I optionally run Flutter Doctor just to see what version is installed. And then we just simply execute the command to build the Android app in release mode. So this is just the standard Flutter command that you would run on your own machine when creating an APK file, and this will build the file. And so this is probably the step that takes most of the time on the CI, and this creates and the output is actual APK. After we have the actual APK, we can then upload our APK, and this artifact is actually uploaded to GitHub Actions. So when you are going to view the workflow run on GitHub Actions page, you will actually see that if it succeeded, you will actually see that there is this artifact that you can actually manually download, and it will be called, in our case, release APK, and it will be just a zip file with an APK inside. And now we can also deploy. In this case, we are uploading to Play Store, and we are uploading it using also a third-party action, as you can see. I know that some people are very skeptical of using third-party actions because they can be maybe not as secure. But what you could also do, you could always clone this action, clone this source code for this action, and then instead of referencing the repo of that person who created it, you can reference your own fork of this action, just to make sure that you keep control under all the code that is run on your CI on your virtual machine. So this action needs our services account JSON file, which also comes from secrets, and needs the package name for our app, and needs the actual APK file that we want to upload. So it's the same one that we uploaded to the artifacts, and we specify a track. In this case, I'm deploying to an internal track and not to production directly. So this is just going to be an internal testing of the APK. So this is what you need to do to get your Android app to build on GitHub Actions. And this is not as bad as it gets with iOS. So in iOS, you need to do slightly more. You also have the same steps to check out the repo, but instead you need to also run on Mac, because you're trying to build an iOS app, and you cannot build an iOS app on any other machine other than Mac. So you're specifying it in runs on, and you give it a Mac latest in our case, and this will be just the latest virtual machine. You can also give it a version for macOS Sierra or macOS Catalina, but in our case we're using latest. We have our timeout set. We are doing the same steps for checking out the repo, but also one extra step that we need to do is we need to set up Xcode version. Why we need to do it here is because we never know when GitHub Actions is going to change their default version of Xcode, and we are just manually setting it to the version of Xcode that we want to build against. So I'm just setting it here to 12.4. And then we need to do one of the complicated steps of setting up the code signing for iOS. So this uses the same kind of idea from the Android key store files setup. We actually store everything in our secrets as a base 64. We store the password for the keychain, the P12 password, the P12 file itself as well, and the provisioning profiles file. And we execute the same steps to turn them into files on the virtual machine onto disk, and then decode them into actual real files. After that, we also need to copy the provisioning profile. So basically, we are manually setting up every single bit of code signing for iOS. Why we are doing it here manually is because if we do it ahead of time before we build the iOS app, then when we build the iOS app, it can automatically pick up all the certificates and provisioning profiles and sign the app without us having to manually resign the app. So this just moves it into the right directory on the virtual machine on macOS machine. So this is exactly where on your own Mac, this is exactly where your provisioning profiles are located. And so you need to basically place that provisioning profile for your app onto the same location on the virtual machine on GitHub Actions. The other step that we need to do, which is also critical, is we need to set up a keychain. So because Xcode uses keychain to access the certificates for code signing, we need to actually create our own keychain. So there's this script which is kind of complicated, and that's why you'll be able to actually take a look at it on the repo. But I'm trying to quickly explain this. This basically just creates a keychain for us, imports that keychain, and then sets this keychain as a default on the virtual machine, and also unlocks the keychain for us to use and sets all the configuration. And I've added a little extra step to clean up all the temporary files for everyone who is scared of it being breached or anything like that by any other third-party steps. After that, we are setting up, just continuing with the build of the app. We are just setting up Flutter, and we are just running Flutter Doctor. This is optional. What's good now is that with Flutter 2.0, this build IPA step is a lot easier to do. But there is one tricky key points that we need to pay attention to. Before we run build Flutter build IPA, which is a new command in Flutter 2, we need to make sure that we unlock our keychain that we previously created in a previous step. And why is that? Is because first of all, the default timeout of that keychain is 300 seconds. And sometimes bigger Flutter apps can take 15 to 30 minutes to build. And that means that by the time we get to signing the app, signing the code, the keychain will be locked and our build will just freeze or cancel or timeout. So in this case, we are setting the timeout to 1,800 seconds, which should be more than enough for the app to build successfully and sign the code. And then we execute this new command, which is Flutter build IPA command. We build it in release mode, and we also pass it export options placed file. And this is a critical part, because if we don't pass it, it won't generate an IPA file. It will generate an Xcode archive instead. But if we pass it this file, it will give us an IPA output, which is what we can then use to upload and distribute. And after that, it's optional to just log the keychain after we stopped using it. And after we have our IPA generated, we can then upload it as artifacts. Similar story as the IPK for Android. And then we can use this Xcode script that allows us to upload that IPA file directly to TestLight. So we have all the details for the user account and a specific password stored in our secrets. And this allows us to directly push our IPA file that we have generated in the previous step directly to test flight. So this we don't need any custom third-party step for this, because Xcode supports uploading files to test flight. And one more job I wanted to cover is this web and Flutter Web, which is very similar to the previous steps. And we also run it on Ubuntu, and we are following the same exact steps to check out our repo, set up Flutter, and build web in release mode. And after that is done, we will have our web folder with all the code, and we can publish that as an artifact. So this is as hard as it gets. The only difference with previous versions of Flutter prior to version 2.0 is that the iOS step is slightly different. I'm not going to talk about all that. It's very similar. The only difference is that how we build the iOS app. So before Flutter 2.0, we didn't have the command Flutter build IPA. We only had Flutter build iOS, which generates an Xcode archive and not an IPA file. So that means we have to manually build an IPA file for us to be able to upload it and push it to test flight. So in this, I'm not going to cover what this does, but you will be able to see this example if you're using Flutter prior to 2.0. So this is very similar. So if I going to show you how this looks like actually on GitHub Actions, so I can share the screen. So this is the repo for this project. So in settings, you will see that in the secrets section of your repo, this is all the secrets that we had to set up for our app, for our code signing. This is everything that you want to keep secret so it doesn't get leaked to anyone. And the good thing is that you can only remove or update them after you added them. And even when you click update, you will never see what was the original value that you added initially, which is good. But the GitHub Actions live under this Actions tab on your repo. And this shows you all the workflows. So you can actually see that this is the workflow that we named Flutter CI plus CD. And we can click on it, and this will just show us a similar page. And from here, we have this option now to run this workflow manually from a branch that we want to run. And because we have that workflow dispatch trigger, event trigger added. And we then see all the workflow runs. So currently we have 20 workflow runs, and some of them passed, some of them failed. So some of them have been canceled. So this is a good example for everyone. So if we go to the one that had passed, for example, we will see what jobs have run in this workflow. And so you can actually see that this job, code analysis and testing, was the first job that had to pass before the other jobs can run, and because they depend on this passing. And if we click into these jobs, we can actually see all the steps that have been executed. So you can see the names and that we added in the YAML file. They are printed out here, so it's nice and easy to read and follow what the structure. And then we can actually expand and see what the output was. So no issues found. Flutter tests, yeah, all tests passed. So that's good. Good job. So then we can actually follow the other steps. You can see what our Flutter web job did and how it ran and what it produced. So you can see that everything succeeded. Same for Android, and everything succeeded except we skipped uploading to Play Store in this case, in this workflow. Same for iOS. And if we go back to summary, we will see all our artifacts. Oops, sorry. So we can see our artifacts on this run right here. So this is our IPK, IPA file, and our web artifacts. We can download them from here and publish them manually, or or deploy them manually to our devices from here. So if I go back to here, and if you have any questions, you can ask me right now. And this is the link for the source code that you can actually go and see the actual YAML code and play around with it yourself and try it for your own app. So if you have any questions, feel free to ask me anything.